AP Calculus AB, Unit 8, Day 5B, Extra Credit Office Hours. These are the answers at the top, multiple choice. Number 1 is D, 2 is D, 3 is B, 4 is C, 5 is D, 6 is C, 7B, 8B, and 9E. So let's try these out. So the first one, we can do a little U substitution. Now these are definite integrals, so we're going to have to plug limits in. So U equals 4x, D equals negative 4 dx. Get rid of the negative 4. So that's going to be negative 1/4 e to the u du. It's going to be negative 1/4 e to the u plus c. It's going to be negative 1/4 e to the negative 4x. Now this is a definite integral, so we can get rid of the plus c. 0 to 1, plug the top limit in first. Minus, plug the bottom limit in second. Minus negative. E to 0. Now e to 0 is 1. So this would be negative 1/4 e to the 4th plus 1/4. Do you see that answer on here? Looks like it's this one, right? So with the negative exponent, you just got to consider that you might have to manipulate your answer to get this. The antiderivative sign is negative cosine. And then we're going to plug limits in. So you plug pi over 4 in. Minus negative cosine 0. Cosine 0 is 1. Cosine pi over 4 is root 2 over 2 plus 1. So do we see that answer? Negative root 2 over 2 plus 1. So there we go. Number 3, U substitution, U equals x cubed, du equals 3x squared dx. This is an indefinite integral, no limits. Don't want the 3. So this is going to be 1/3 cosine u du. So it's going to be 1/3 sine u plus c. So that's going to be 1/3 sine x cubed plus c. 1/3 sine x cubed plus c. There we go. Number 4, use U substitution. They're telling you what to use. Okay, well, that's probably what I would have picked anyways. Du equals 2x, 2 dx, don't want the 2. So that's going to be, now this one's interesting. That's going to be 1/2 square root of u du. Now all the answers, we're not actually going to finish this one. All the answers have the square root of u du in the 1/2. Right? I mean, these ones don't have the 1/2, so they're probably out. But the only difference between these are the limits. Now, the thing that people are going to want to do is they're going to want to pick the one that has 0 to 2. That's the wrong answer because these are x values. These are x limits. If you're going to choose an answer with all the u stuff, then the limits have to be u also. So these are x values. The u values, it's easy. You plug this in to the expression for u. If u equals 2x plus 1, plug x equals 0 in and u equals 1. Plug x equals 2 in and u equals 5. So you want the one that's u1 to 5. This one. So if you're picking an answer with all the u stuff in it still, it hasn't been changed back to x, then you got to change the x limits to u limits. I usually don't change them and change everything back to x and then finish the problem with the original limits because I change everything back to x, which you don't have to do. Number 5 says the graph of f prime, the derivative of f is shown in the figure to the right. f0 equals 5, then f1 equals what? This is the graph of the derivative. So should we maybe try and figure out what the equation of this line is? It's going to be y equals going down 6 over 1, rise or run, negative 6 over 1, x, and then the y-intercept is 6. So the equation of this line is y equals negative 6x plus 6. So what we could do is we could say, okay, if that's the equation of the derivative, right? F prime of x equals negative 6x plus 6. So if you want f, you're going to have to integrate f prime. So you're going to have to integrate negative 6x plus 6. So you're going to get negative 6x squared over 2 plus 6x plus c. Now we can find the c because we have the initial condition. So we're going to plug 0 in here. Negative 3, 0 squared plus 6 times 0 plus c equals 5. That goes away, c equals 5. So the function is going to be fx equals negative 3x squared plus 6x plus 5. And now we can plug 1 into it and see what we get. So f of 1 equals 8. Okay, kind of interesting. All right, got a few more. Okay, it says number 6, the regions A, B, and C in the figure bounded by the graph function f. Okay, regions A, B, C in figure bounded by the graph of the function f and the x-axis. If the area in each region is 2, what is the value of this? So I guess saying they're all 2. The area of this is 2, this is 2, and this is 2. Okay? So then what is the value of this integral? So if you're to integrate this, I would say, well, let's break it up. Let's do negative 3 to 3 of f of x dx plus, you have to integrate the 1. You can't just say plus 1. Now, the integral from negative 3 all the way to 3 is going to be negative 2 plus 2 minus 2. That's just for this. And this guy, you can integrate and say that the antiderivative of 1 is x. And then you could plug, so this is going to be negative 2. And then this is going to be 3 minus negative 3. So that's going to be 6. So the final answer is going to be 4. Another way you could have done this is you could look at the graph of this and say, well, it's the graph from negative 3 to 3 of a horizontal line 1, and you're trying to find the area. Base times height, 6 times 1 is 6. So the answer is 4. Number 7 says, for all x in the closed interval 2 to 5, the function f has a positive first derivative and a negative second derivative. Which of the following could be a table of values for f? Well, they've got to be going up. Positive first derivative. They got to be going up. Plus 2, plus 3, plus 4, plus 4, plus 3, plus 2. Those are both good. Minus 4, minus 3, minus 2. This one is out. That's a negative derivative. Minus 2, minus 3, minus 4. That one's out. It's a negative derivative. Minus 3, minus 3, minus 3. That one's out. It's a negative derivative, right? So these are positive derivatives. Now it says negative second derivative, which means that the derivative is decreasing. The derivative of the derivative is negative. So the derivative is getting less and less, decreasing. So it's going up by 2 and then it's going up to 3. This is a positive second derivative because the derivative of these values, it's getting bigger and bigger and bigger. Here, it's getting smaller, smaller, and smaller. So this is a negative second derivative. Concave down, it's getting less and less steep. So remember, second derivative is concave down. That means the slope is getting less and less and less, and even maybe more negative. Concave up means the slope is getting big, less and less negative, more and more positive, bigger, bigger, bigger. Okay, so the answer is B. 8, the velocity function f of t of a particle moving along the x-axis. This is the velocity equation. What is the average velocity of the particle from time? You can use graphing calculator, but you got to set it up. So velocity is the derivative position. So average velocity is the average derivative. So mean value theorem says if you want the average derivative, the average slope of something, you plug in the endpoints and you just do rise or run between the endpoints, the slope of the secant line. Okay? So now let's see. Average velocity from time 0. Okay, so we don't have the actual position equation. So how are we going to find these? Let's see. What is the average velocity? This is how we should do it. So I don't know, do we need to try and find the position equation? So the position equation would be the integral of s prime, which is velocity. So I don't know if we need to try this separately. So s of t would be the integral of e of t plus t e of t dt. But I don't think we're going to be able to integrate that either. So now in my work, I did this, V average. I wrote this down, but then I wrote V3 minus V0 over 3 minus 0, which does not make sense. That would be average acceleration. So this should make sense. This is what I put down as my answer. There's one other thing that I don't think is fair to ask you in this question, but there's another way to find average of any function. It's mean value theorem for any function. I don't think I've really shown it to you. If you integrate the original function that you want to find the average of, velocity is a function, you find the area from 0 to 3, and then you divide it by the base of that area. That will give you the average value. So on your graphing calculator, we could do this, because I don't think we can integrate this by hand. So we could do math 9, and then it is e, we'll put x's in, plus x, e to the x, close, comma x, comma 0, comma 3, and it gives us that, and then we would divide it by 3. That would give you the answer. So this would be 1/3 of 60.25661077, which gives you 20.085. That's our answer, or 20.086. So the answer should be A. It should not be B. That would be average acceleration. So anyways, you guys aren't really ready to do that one, but that's how you do it. Okay, number 9, particle moves along the x-axis so that anytime t is greater than 0, generally we don't do negative time, its acceleration is given by this. If the velocity of the particle is 2 at time 1, so that's velocity 1 equals 2, then the velocity of the particle at time 2 is what? So, well, if you want to find the velocity equation, you could integrate the velocity derivative, which is the same as the acceleration function, which is natural log of 1 plus 2 to the t dt. The problem with this is we can't integrate that by hand to get the plus c, and we could use this to find the c value, but I think we're kind of stuck here. So you have to use something else, the fundamental theorem of calculus, which I don't know if I've shown this to you guys yet much. Fundamental theorem of calculus part 1. Another way of doing this, and we kind of wrote this down, is if you integrate a derivative, which in this case is acceleration, right? You get the original function, and then you plug the limits in. So if you know at time 1 and you want time 2, then you could plug those in, you get v2 minus v1. And then this way you could find v2, because v2 is now going to equal v1 if I add this to the other side, plus the integral of 1/2 of the acceleration. So this is something we call the fundamental theorem of calculus part 1. Well, we've already shown that to you, but in a way, we haven't really used it like this. So now V1 was 2. And then we can use our calculator to do that. So math 9, natural log of 1 plus 2 to the x, close, comma, x, comma, 1, comma 2. So that's 1.34613. And so the answer for V2 would be 3.34613. 3.346. So again, that's something I haven't really shown you how to use, but hey, it's a little sneak peek, and I showed you how to do it now. So that's how you do it. All right, that's it.